Now, it is my pleasure to invite Dr. Cynthia Rosenzweig to deliver the first keynote speech. First of all, please let me introduce Dr. Cynthia Rosenzweig to all of you. Dr. Cynthia Rosenzweig is a senior research scientist at the NASA GISS, which is Goddard Institute for Space Studies, and the co-located Columbia University Climate School's Center for Climate System Research. And Dr. Rosenzweig's specific area of expertise is climate change and food system. At NASA GISS, she heads the Climate Impact Group, whose mission is to investigate the interaction of climate, both variability and change, on systems and sectors important to human well-being. Dr. Rosenzweig is a co-founder and member of the Executive Committee of the Agriculture Model Intercomparison and Improvement Project, which is namely ADBI, a globally integrated transdisciplinary study of climate change and the food system at regional, national, and global scales, including the participation of over 1,000 leading researchers from developed and developing nations. She has developed a new method of detection and attribution to observed changes in physical and biological systems to astrological greenhouse gas emission, and pioneered research on the impact of and adaptation to climate change and climate variability. In 2019, Dr. Rosenzweig was coordinated lead author of the food security chapter for the IPCC Special Report on Climate Change and Land. She is the 2022 recipient of the World Food Prize, considered as the Nobel Prize of Food and Agriculture. Now, please join me to welcome Dr. Cynthia Rosenzweig to deliver his keynote speech. Thank you. Please, now the floor is yours, Cynthia.
Thank you. Thank you very much to the Asian Development Bank Institute and for inviting me to speak at the annual conference this year. Thank you to the organizers, and thank you to Dr. Yao for the introduction. As she said, I'm going to be speaking a lot from experience with the with AgMIP, the Agricultural Model Intercomparison and Improvement Project, on fostering resilient food systems in a changing climate. I'm going to share my screen now. Let me do that, and I will launch into the keynote. Here it is. There we go. Can you see? Is that working? Good. All right. So here are some of the sites that AgMIP has worked in Asia. The outline of the keynote is the following. First, what is the climate change challenge that agriculture and food systems and supply chains are facing? What do we need? How can we work together to advance solutions now, as we are in really the decade of action for climate change? And so I'm going to then share about how AgMIP works, a little bit about how it works and the radical collaboration that it is. Then to give some brief examples of some of the methods and tools that AgMIP uses. Then now beginning to look forward, what do we need to do as researchers to work together in better, more effective ways? So that leads to breaking down silos, and then offer some ways forward at the end, and also a challenge to all of us including the great leadership of the ADB and the ADBI on really fostering the kind of projects that are needed going forward. So let's go right away to the climate change challenge. Here we are from the IPCC, Intergovernmental Panel on Climate Change, 6th Assessment Report, annual mean temperature change relative to 1850 to 1900 at 3 different levels of average global warming from pre-industrial times. On the left, we see the 1.5 global warming, what the temperature changes around the world would be. And of course, we're focused on agricultural regions at this conference. And that is the goal of the Paris Agreement of the United Nations Framework Convention on Climate Change. Now, in the Paris Agreement, it also mentioned 2 degrees warming. That's the middle graph, the middle set of projections on what the agricultural regions would look like, or the world, of course, but that's what we're focused on, with 2 degrees warmer. And we know from the work of the IPCC that even that 0.5 degree difference in the global surface temperature warming makes a large difference on what the agriculture and food outcomes will be. Then on the right, of course, we have simulated change at 4 degrees C global warming. And this, unfortunately, is the path that we are on as a world society with the greenhouse gas emissions. This is really what we are facing if we don't, as a global society, come together to reduce the global warming to either, we hope, 1.5, but even 2 degrees is a major goal. So what does this mean for agriculture? So this is showing work that we did led by Jonas Jägermeyer of AgMet. It is with 12 global gridded crop models, 5 global climate models. And again, this is similar to that right-hand map that we were looking at with the intense 4 degree mean warming. And this is for maize yields and wheat yields moving through this century to 2099. What we see is that that climate change the effects of climate change will vary by commodity. Here we have rice, here we have wheat yield with very different. This is more with the reds and yellows and oranges are negative effects, and the wheat yields in the higher latitudes are primarily positive due to high CO2 effects, high carbon dioxide effects, and the more moderate temperatures that can withstand the warming. So we need to, but we see also every region is different. And we need to be looking at Asia, of course, to see what these projections of both the climate change and the commodities mean. That these projections are without adaptation. That's where our job as researchers come in, to develop the adaptations so that these in particular negative aspects, negative outcomes are minimized. Oops, let's go to the next one. Now, I think for a long time with climate change and agriculture, we were looking at these curves down at the beginning of the warming curves from 1880. These are the temperature average temperatures over land with observations. And what we see was that we saw warming, but it wasn't really until the 1970s, really the 1980s, that this rapid warming occurred. And this is over all the agricultural regions. This is just focusing on the land where the agricultural regions are. And so with this rapid warming that the world is experiencing now, there comes this much greater sense of urgency that we address climate change, agriculture, and food really urgently and concertedly now. Now, we were just looking at the mean warming, but of course, we all know that what this means, that those warming temperatures bring changes in extremes. Here are just some examples that I'm sure you're all familiar with. Madagascar, a climate-induced famine, Pakistan, the flooding based on the intensified monsoons there, and here's in Chile, many declarations of agricultural emergencies there during drought, and here in the 2022 heat wave in India, in fact, impacted wheat, fruit, and vegetables, as well as livestock. So it's these increased frequency, intensity, and duration of the extreme events that is creating the urgency now for us to really work for solutions. And then, of course, right now, the Ukraine war having a tremendous effect on supply chains, as well as on production. War's disruption to grain and fertilizer flows have prompted the worst food security crisis since at least the 2008 financial recession. And with some over 300 million people now facing life-threatening shortages, many of those in Africa. So how can we work together to create the solutions that will address these challenges? So AGMIP is a radical collaboration to work together in new ways. We are so that we can rise to the challenge of climate change. We are AGMIP is a global network of over 1,000 agricultural, climate, and food researchers. AGMIP convenes scientists and the stakeholders. We have to have the decision makers with us right from the beginning to conduct multi-model assessments that can then project both the biophysical, as we were looking at the crop yields, as well as the economic impacts. All the global economists are with us as well, and with their trade models of practices, technologies, and incentives, policy incentives for current and future climate conditions. The outcome of all of this, and I think an expanded network of networks, of course, is to provide the science base for decision making around climate change action. So just to prove to you, these are that we truly are a worldwide community. We started in 2010 at the first AGMIP Global Workshop. We do regional workshops such as in South Asia. Of course, during COVID, we had to meet virtually, but AGMIP kept on providing very rigorous work for the IPCC and elsewhere. And I'm going to be showing you some examples of the work of AGMIP. And this group comes together to provide science-based, this is the mission of AGMIP, science-based agricultural decision-making models and assessments of climate change to achieve local to global food security. This scale issue is very, very important because still on the ground, right here in Nepal, where we held one of our project workshops, agriculture is always based on the ground, but at the same time, what are the national scale implications and policies that can help with actions, and what is happening at the global scale as well? And AGMIP works at all of these scales. So what kind of methods and tools are available? Here's just a few examples, and I know that there are many more from all the folks at this conference, the colleagues at this conference. But just to share a little bit more about our integrated regional assessments. These are the features of them. First of all, let me just go over the scales here. So we take some aspects because they're coordinated across scales. So we take global and national prices, productivity, and representative pathways and scenarios at the global scale. Then we look at the regional scale at complex farming household systems, and we see and we incorporate the heterogeneous aspects across the agricultural regions. And this is very, very important because then you don't get just one answer, you get the distribution of answers. And we then test adaptation packages of technology adoption, distribution of economic environmental and social aspects as well. And then we link back to the global scale to test how are those global models doing down at the regions. We do subnational regions to national and global. These assessments are stakeholder driven. We have to link them to decision making right now, focused on farming systems, take development pathways into account, are transdisciplinary, bringing together biophysical and socioeconomic scientists and researchers, multi-scale, as I've described, multi-model to get the rigor of so that we can, with our multiple models, provide much more rigorous projections of what the outcomes will be. And then very importantly, the methods used provide distributional results so that we can look at what are the impacts on poverty rates across the farmers in any given region. Now, here's an example of geospatial modeling that AGMIP does. This is from the United States, Bruno Basso at Michigan State University. On the left, we see the percent change in slow organic carbon from conventional tillage to no tillage and cover crops. The dots are the individual farms that participate in the study, and then remote sensing is used for the broader spatial aspects. On the right is percentage change in cumulative nitrogen leached, another major environmental problem, with no-till, cover crops, split application of fertilizers, and organic amendments. So this is the kind of work that AGMIP does at regional scales. Now, we also use artificial intelligence we develop new models trained on field observations to really draw added value from the combination of observed weather, remote sensing of field conditions, and crop model results. And what we find here in using, in this particular use of machine learning and artificial intelligence, is it helps to identify areas for crop model improvement, like where are the models working, but also where are they not working? So just one example, the AI has indicated the important role of frost and floods. And we have to make sure that the models in our model development are doing a very good job on those processes. Now, finally, on the methods and tools, how do we scale this out so as many people as possible can utilize this kind of science-based information for decision making? So this is the example of the AGMIP Impacts Explorer. It has regional summaries, it has a spatial dashboard, and a data explorer, because different groups of stakeholders and decision makers, some want the regional summaries, others want to delve right in and have all the data themselves, of course, to do analyses on their own. What about breaking down silos? This we feel is very important in AGMIP, and AGMIP has a lot of experience in doing this. For example, bringing together the crop modelers, the climate modelers, and the economists, for example. So, but the breaking down of silos that I want to focus on right now is on mitigation and adaptation. There's been a tremendous bifurcation of the people who work on reducing greenhouse gas emissions from agricultural processes to adapting agriculture and farming systems under changing climate conditions. But you know, these things in agricultural systems are not really they're all with the same system. So studying them so separately has, we think, led to some this bifurcation and siloization. So AGMIP is developing a program called Mitigation and Adaptation Co-Benefits, Synergies, and Trade-offs. And I think that Dr. Sonali McDermott will be sharing more about, we call it MACB, in her presentation, in the presentations to follow. But what we do here, just focusing right now on, what we really are now doing is bringing the models that are used for emissions and reduction of emissions together with impacts and adaptation models and the scenarios of climate change, because both of these major responses to climate change, mitigation and adaptation, will be happening together as we march into the future. So this is, and we're looking, and the results of this are synergies, trade-offs, and co-benefits. I'm going to give some examples in a moment of the kind of processes that we're looking at in MACB, and to see what policies and programs from working with stakeholders from the get-go in the projects. So MACB is being conducted in Asia. One project very much led by Dr. McDermott is in India. And as you all know, rice is often grown with complete flooding of the fields, and that this is a major source of methane emissions. In Vietnam and India, and Dr. McDermott is working on both locations, AGMIP models suggest by doing alternating wetting and drying of the field so that they're not continuously flooded, farmers could reduce methane emitted and in some places boost their yields. So far, early results in India show an increase in yield about 27% and a roughly 38% decrease in methane emissions from alternate wetting and drying. So there's some encouraging, promising results, early results there. Another example of MACB project that AGMIP is doing is in Bangladesh, and we have a wonderful team, and Dr. McDermott is leading the climate team there. We're using CMIP6, climate projections from one SSB and 2 GCMs. We're using 2 different crop models, and data coming from field surveys in Bangladesh and soil data from Soil Grid 2.0. Here again, we're testing simulations of alternate wetting and drying at the regions you see on the left. A wonderful team of Bangladesh researchers who are on the ground in Bangladesh doing this research. And we also see strong reductions, in this case, not only on water requirements for irrigation, of course, if we're alternating wetting and drying, but also the C4 emissions as well. So let's turn now to how do we go forward as researchers, really providing the science base for decision-making for the decade of climate action that has been so called for in regard to food at the recent COP27 in Sharm el-Sheikh in Egypt. So the first thing is, the first way forward is to utilize a food system approach. So still so much work is focused on production, as it needs to be, but we need to be looking at the pre-production in fertilizer manufacturing, equipment manufacturing. We need to, of course, be looking at land use with deforestation, expanding rangelands, draining wetlands, peatlands, and burning of savanna, for example. We need to also very much, and so much the focus of this conference is on the post-production side, processing, packaging, transportation, where the supply chains come in, refrigeration. Then let's not forget diets and consumption, food preparation, homes, restaurant and retail, dietary choices, institutional purchasing, and of course, throughout the entire system, food loss and waste. So AGMIP is working with FAO to develop databases by country of the greenhouse gas emissions from all of these components of the food system, as well as looking at how the climate change will be affecting those on the adaptation and resilience side. So to wrap up the way forward, take a food system approach that links the climate system, ecosystems, nutrition, and sustainable development pathways to achieve healthy food and a healthy planet. So food system approach is the first way forward. The second is, I believe, to keep a laser focus on climate change solutions for food system stakeholders with an integrated focus on mitigation and adaptation. Remember, that's MACB at the same time, and of course, sustainability. Finally, to conduct radically cooperative. That's like AGMIT, but let's join all the networks together and develop this. We hope to develop even more integrated assessments regionally in Asia to bring the modelers and the stakeholders and the researchers together to perform multi-scale assessments of solutions, and including the resilience to climate disasters. Just remember back when we showed those climate extremes and the examples that they are having right now on food security. So as the World Food Prize winner this year, I've been asking our communities across the world that's why I have at the bottom my ask, for us together to develop larger scale climate change resilient food system solutions. We now know, I think, a lot of what we need to do. What we need to do now is scale up and scale out. So with that, I want to invite you to the 9th AGMIP Global Workshop, which is going to be June 26th to 30th in 2023. It's going to be at Columbia University, New York, New York. And these workshops are roll up sleeves and work together kind of workshops. Sonali, I'm sure would agree. So please save the date and come. It'll be hybrid. So come either to New York, and so we can all meet together, or also there'll be plenty of online opportunities as well to really move forward in radical collaboration for climate change solutions. So with that, I want to thank you for inviting me to give the keynote. For protocols, up-to-date events and news, and to join AGMIP, please visit the website. Thank you very much.